Welcome. In this video, we will learn about groundwater importance. By the end of this video, you should be able to recognize the importance of groundwater, uh, explain why groundwater uses in Florida, and understand the ecological significance of groundwater. So groundwater is not only important for human use, but also for it provide like multiple ecosystem services, as we will see in this lesson. Yeah. Okay. So let's get started. So here is some of the uses of groundwater. I just selected like a few of them that might be of relevance to this class and to engineering student. One is agriculture. So groundwater, it like about 40% of the food supplies that we get worldwide is from groundwater. So 40%, like the irrigation water, is groundwater. But other than irrigation, groundwater, I want you to, this more like a thinking or like a thought exercise. So maybe just pause like the video for a few minutes. Yeah, and think about each of these terms, like why would groundwater, so it's obvious groundwater would be important for irrigation. You use it for as irrigation water, and it provide like 40% of the groundwater. But for drainage, for example, nutrient uptake and fertilizer efficiency, why would groundwater be important for this thing? So I want you to pause the video and think about. Similarly with engineering application, like read these different application and think why would groundwater be important for soil substance or drainage, or like drainage here would be very different than drainage here. Yeah, slope stability and earthquake, for example, geothermal energy and environmental. Okay, so pause the video, think about this, and then we will discuss. Okay. Okay, welcome back. Groundwater is important for drainage because the groundwater level directly affects soil drainage and water logging condition in agriculture and urban area. So in agriculture area, you could have like, if you have a very shallow groundwater table, you could get water logging and the land could get flooded with water. Could be useful sometimes, maybe if you are doing some rice irrigation, but for other crops that might not be useful. So that is for drainage. For nutrient uptake, like why would groundwater be important for nutrient uptake? Again, uh, adequate groundwater availability, and like if you have like higher groundwater level, that could ensure like optimal soil moisture, and that will facilitate the plant nutrient uptake. So that's also one factor why how groundwater affects agriculture. What about like fertilizer efficiency? I mean, what does groundwater has to do with fertilizer efficiency? Again, similar reason, like if you are have a proper groundwater management, that will enhance fertilizer efficiency by maintaining optimal soil moisture condition for plant absorption. So if there are optimal soil moisture condition, plant will be able to absorb nutrients, different micro macro and micronutrient from the soil, and then that could improve your fertilizer efficiency, like how nutrients like nitrogen or phosphorus you put into the soil. Yeah. So that is with respect to agriculture. So groundwater is very important for agriculture. How about engineering? Like as an engineering in engineering, like how groundwater could be other than water resources, for example, like water resources engineering. So if you're a water resources engineer, you could be either working in surface water or groundwater. These are the two main groundwater resources. But other than water resources engineering, like other types of engineering, how could groundwater be important? So for example, soil subsidence. So soil subsidence, when you pump groundwater, when you have heavy pumping, this could cause soil subsidence. Like you can cause soil subsidence. You see this, for example, in Louisiana. You see, and you have soil subsidence, so the land will go down, and plus sea level rise, so that could, for example, make flooding worse, and especially in hurricanes, for example. Yeah. So that is soil substance, but soil substance not only in coastal region, it could be anywhere, and soil substance could affect the integrity of several structures. So, for example, in some big cities, urban area where you have extensive groundwater modeling, structure, building structure, and like historical building, you find that this will damage the foundation of historical building or other buildings due to soil subsidence. How about drainage? So drainage, if you are, for example, a geotechnical engineer, then you need to learn about groundwater because you need to drain the site. Like if you're building a having a building and you're doing a foundation, you need to drain uh, your site, your construction site, where the foundation will be before you start construction. So you will need to install some pump drains the water out and keep the area dry and drain so that you can install your foundation, for example. So that is how it is important for drainage. Slope stability and landslide risk that could also be affected by groundwater. So you see, so that is also another factor where groundwater, like if you're designing, like making a design where you need to maintain certain slope stability, you need to account for groundwater and the pressure that groundwater will induce. Yeah. Geological processes like earthquakes, yes, so groundwater could uh, also induce earthquake. For example, if you are doing injection, so sometimes we pump water out, but sometimes we inject water in. Like we inject water in for different reasons. Like there are certain things we want to get rid of. That's we do this here, for example, in Florida, where we in some injection, like deep injection, we can like if you have some fluids you want to get rid of, you do deep injection in deep formation, deep aquifers and deep groundwater formation. That's one reason. But another reason where uh, earthquake could be very active is fracking. I don't know if you've heard of this. So this is like non-traditional oil when you do fracking and you inject uh, water and other like fracking fluid. So there could be like a fault, like an inactive fault, and you just when you inject this water, you replicate this. You do like rubrication for this fault, and then you can have like a major earthquake because you'll be injecting water and act. Another also engineering application for groundwater, like geothermal energy that could be like based on urban heat island, or geothermal energy could be also based on heat pump. So if you want to install a heat pump or urban heat island study or use like urban heat island, so that's also another engineering application of uh, of uh, of groundwater. Yeah. Environmental and health, you have a groundwater dependent ecosystem, which we'll talk about. You have drainage and flood control. So in urban area, for example, like here, like at FGCU, for example, where you have a very shallow groundwater, and if you have because the groundwater just gets saturated until it reaches the level, and then uh, you could have this flooding issue like on campus. Yeah. Water storage. So I mean that's the most obvious use for, of groundwater is that it's store water and you can use this water at any time. So let's say even if don't depend on groundwater, we will see like who depends on groundwater more. Like some states here in the US depends on groundwater more than the other, but that could be like water storage for like a drought buffer. Like if you have a drought period, then you can use this groundwater. So it's like you have an underground like storage tank for water. But other issue could be like health issue. So groundwater, it's help to protect the drinking water sources like from contamination. So you usually have unconfined. We will learn about this in detail and like unconfined and confined aquifers. So confined aquifers, this usually have very good water quality because it's like a natural filter, like water flows slowly in like the sand unit or whatever underground formation, and that would be like you get a very high quality water. But also there could be other health issue which we'll talk about later. Yeah. Soil degradation. That could happen like through salinization and help you to improve your soil health. Okay, so that's why. So let's look here at groundwater. Uh, it is the most available non-frozen fresh water on Earth. It is the most available. So let's look at this figure and let's do some calculations. So this is the total global water. Like this is worldwide. This is how much water we have. So as you see, uh, the ocean is about like 96% of all global water, and then you have about 1% like other saline water, like salt marsh and uh, things like that. Yeah. But that's more importantly is the fresh water. So like fresh water is only 2.5%. So basically most of the water we have on Earth is saline water. Okay, but this 2.5%, about like more than two-thirds of it, are actually not available, or more precisely, these are frozen water, like in terms of like glaciers and ice caps. So that's their main use. They are used as glaciers and ice caps. Yeah. But other than that, you have 30%, yeah, of like this 2.5% is groundwater, and surface water and other fresh water is only 1.2%. So groundwater is 30% of the available uh, uh, fresh water on Earth, and the groundwater is more than 97% because this is like 31.1 and this 1.2. So groundwater you see here uh, is more than uh, 95% of the fresh non-frozen groundwater is not surface water, is groundwater. So let's do, you can calculate this number like total percent of the total Earth's water. Like pause this video and calculate these two numbers, like groundwater, like giving this data on the screen. Pause this video and calculate these two numbers. Like what is the percentage of total Earth water, like groundwater, and then the percentage of non-frozen fresh water, like groundwater, is accounts for what percent of the non-frozen. Yeah. So pause the video and calculate this percent. Okay. So welcome back. So if you did this calculation, so you will see here. Mm, see if I can write something here. Oops, I cannot write something. Let's see how can I do some. Maybe here we go. Okay, here we go. So with the pen, so that is like if you did the calculation correctly, that would be about 0.75. And if you did this would be about like this would be like more than 95%. Yeah, so more than 95%. So in some sources, you will, I just wrote more than 95%. Like in some sources, you will see like 97%, and in some sources, you will see like 99%. Okay, so the non, so groundwater is 90%. In some sources, you will find this number, in some sources, you will find this number. Okay. Okay, so uh, some other numbers like what are the groundwater supply and use. So in the US, like worldwide, like so you can have like these numbers like worldwide. Let's see here, screen substitute. Okay, here we go. So worldwide, uh, groundwater, like the amount of water, groundwater we extract each year is about like 1,000 kilometer cube per year. That's how much groundwater, about how much, a little bit less than this number, but just on average about how much groundwater we extract per year, like worldwide. Yeah. Here in the USA, 23% of the US fresh water like comes from groundwater. So in the US here, we extract about 80 billion gallon per day out of the 341 billion gallon per day total. Uh, is groundwater. Yeah. So that's how much groundwater here in we extract per day. Yeah. So in America, in US, here in the US, about like 44% of Americans like here we drink groundwater. In Europe, this is a little bit higher, like 75%. Irrigation. So this for water supply. Yeah. For irrigation, uh, the US use about uh, 55 billion gallon per day groundwater used in the US. That's like for irrigation. Okay. So surface water contribution. Okay, so this is a big number here. 49.2 billion gallon per day flow into surface water body, like major sources for lakes and wetlands. So that's the biggest contribution of groundwater is actually to surface water. So about like 492 billion gallon per day flow into surface water body, like groundwater. About that's how much groundwater. So each day, about 500 billion gallon per day of groundwater will flow to surface water body like lakes and wetland. And we will see this in details, like how groundwater flow into surface water and how groundwater is important for surface water. Yeah. Uh, okay. So this is here you see like a groundwater withdrawal. So this is the states where there are like how much groundwater withdrawal in like million gallons per day. So you see Florida here, we withdraw about like 200 to uh, 5 million million gallon per day of like groundwater, for example. In California, they withdraw about like 10 to 20,000 million gallon per day, uh, and so on. But this is just like how much groundwater is being withdrawn. So you see, like it's most like here in Texas, in Oklahoma, uh, Nebraska, a lot is used here for agriculture. Kansas, so here this is uh, high plain aquifer, and this is one of the largest, like non-renewable aquifer in the USA, and like a lot of this water is used for irrigation, for example. Yeah, uh, and California, and so this is just how much groundwater is being withdrawn. But let's look at this is a different one percentage of population using groundwater and drinking water in each state in the USA. As using groundwater as drinking water. So you see here, like in Florida, Florida is aquifer dependent. So 93% of the Florida population, they depend on groundwater, yeah, for drinking. Uh, See, like in Hawaii, for example, 94% in certain region in Hawaii. So that's why, for example, I'm working here in Florida because I'm a groundwater hydrologist. So this is any groundwater hydrologist. That's why I work it also in Hawaii, because in certain parts of Hawaii, the groundwater uses like it's 100%, like all drinking water come from groundwater in certain parts of Hawaii, but statewide it's like 94%. California, for example, they are one of the biggest users of groundwater in the USA, but not necessarily for drinking water, but mainly for agriculture. So agriculture is groundwater is very important for agriculture in California as well as Florida. So here in Florida, we use groundwater. It's very important for agriculture, but it's also very important source for drinking water. So you see here, Nebraska also like groundwater is important. Texas, uh, Louisiana also like 61%. So this is basically like a map will show you like a Minnesota like 80%. Sorry, this is oh yeah, this is Minnesota. Yeah. This is Michigan. So you can see like here where groundwater is like important as a source of drinking water. Yeah. And that's basically, yeah, okay, where you can also need groundwater. But you see like in almost all the state, like groundwater is important for drinking water. Yeah. Okay, so let's look more here in Florida, like more than of the population rely on groundwater. Like we see that we already like 93% of the drinking water comes from groundwater. So here in Florida, this water is supplied by like different types of aquifers. So like the most famous of this is called like the Floridian aquifer. You see here is like it's like deep down. It's like deep down. It's mainly like limestone karst aquifer. We will learn what karst aquifers. So there are porous media aquifers, there are fractured rock aquifers, there are karst aquifer. We will learn this later in the course. So karst aquifer, these are the type of aquifer where you find like conduits and caves and like these type of features. Yeah, this is called karst aquifer, and it's like a limestone basically. So limestone aquifers, that would be like a karst aquifer. That's another name. So you have like some aquifer are made of like sand sediments, for example. These are porous media aquifer, and aquifer made of limestone. These are called karst aquifer. Karst, K-A-R-S-T. Yeah. And you can Google it and see some beautiful image of these karst features. Where is this Floridian aquifer? That's almost in it just it is underlie all like the entire state of Florida, portion of Georgia, Alabama, and even South Carolina. So it extends all the way to South Carolina. The Floridian aquifer. It is one of the most productive aquifer in the world. Its primary use is drinking water, mostly in north and central Florida, supplying water to major city and rural community alike. This aquifer was mainly recharged in the last glacier period. Yeah, last ice age. Yeah, that's when it was mainly recharged, the Floridian aquifer. Uh, so its use, it has like very high quality. So it has a very high quality, abundant water. It's supplied for like agriculture and industrial, not only for drinking water, but also for agriculture and industry. Here in South Florida, we use it differently because here in South Florida it's like deeper, and it's more brackish, like saline brackish, like slightly saline, and it serves as a zone for disposal. So treated like wastewater, we get injected there through like deep injection wells. That's like in South Florida, yeah. Some also coastal community in South Florida, they utilize part of the Floridian aquifer for like desalinization. So they will desalinize the water and use it. Yeah, that's one aquifer. Another aquifer which you will find also in Florida, in Miami, and uh, like Miami-Dade County and Port Ward and Palm Beach counties. That would be the Pisican aquifer, and that's very important for supplying water for this big Metropolis area. So it is shallow, it is unconfined, it's limestone aquifer. It's highly permeable limestone, and so allow for rapid recharge from rainfall and make it like susceptible to contamination because it's shallow, it gets rapidly recharged and rapidly discharged, so it's susceptible for contamination from like surface pollution. This is the primary drinking water supply for Miami-Dade, Port Ward, and Palm Beach counties, and also serving like millions. So this would serve millions, and also important for irrigation. Yeah, so also part of this water would be piped to supply like Florida Keys. That would be the Pisican aquifer. Uh, Other important aquifer also in Florida, that would be the sand and gravel aquifers that would supply mainly in the Western Panhandle, the sand and the gravel aquifer. That's the main handle. But you see here also there is the superficial aquifer system and the intermediate aquifer system. These are semi-confined sandy limestone layer. And these were are used localized. So this will have like, so for example, like the sand and gravel aquifer, that will mainly in the Panhandle area in the northern area, but the superficial and intermediate aquifer systems that would be like for localized use. Some many city across the state will use it for like lawn irrigation, for example. But it is also used for agriculture and domestic use. So, for example, like in deeper part of this aquifer, that in Sarasota, for example, and Lee County, they can be used for drinking water. Uh, it also, like in Immokalee, for example, this aquifer, the aquifer would be used, the surfacial aquifer would be used for agriculture. And similarly, also the intermediate aquifer would be also used for agriculture in Immokalee, for example. Yeah, so that have like different uses. Okay, so this was just like a quick overview on like the four main like aquifer system in Florida. Again, the Floridian aquifer, the Pesican aquifer, the sand and gravel aquifer, and the superficial and intermediate aquifer. So here, your this is like your participation activity. You will be doing this in the discussion. So what you will do in the discussion uh, is that I want you to in the discussion, I want you to just Google Florida aquifer and find like any documents that could be like a USGS report, like a research paper, a book, whatever, and learn about like select any aquifer in Florida, any aquifer of your choice, yeah, and any aquifer of your choice and just post some information about, just as I was discussing now, like what is main formation, what is primary use, where it is located, how it is used. Yeah, like location, primary use, key characteristic, any interesting fact. Yeah, so post like, so read and just post like this information. And then that's one part. So for this, you'll get half of the grade. The other half of the grade would be read through the post of your classmate and like and comment on your favorite one. So you will post something, your other classmate will post something, and then read through these posts. And if you, that's like, if that's your favorite one, like you can like, just hit like or comments on it or whatever. Yeah. So I want you, like the reason I give you this exercise because usually you learn more when you learn with other students, not just when you learn alone. So like these type of discussion and interactions that will help you to learn more. So this is basically like some strategy to help you to learn better. And that's why I like you to just do to post something and interact with your classmate and discuss and learn together. Yeah. Okay. That's also the fun part of an online class is that you get chance for these types of interaction and they are fun. It's like, you know, you'll post something, you will read the other post of your classmate. Is like going to, you know, I don't know, social media or whatever and reading some posts there, except that this would be groundwater type of posts. Yeah. Okay. So now here in the rising demand, so groundwater will be about like 1 billion gallons per day by 2030. So that would be a total of nine. Uh, uh, so that would be a total of 8.5 billion gallon per day. So in Florida, you will by 2030, this is expected demand would be about 8.4 billion gallon per day. Yeah. Okay. So right now it's about like yeah, uh, 700,000 million gallon per day, and it's expected to be like 8.5 thousand million gallon per day or 8.4 billion gallon per day. Groundwater dependency, like 90% or more than 90% of the state population depend on groundwater. Groundwater depletion in northeast Florida, it's about like one third to half foot per year, dropped like since the 1950s. That's like groundwater depletion. In the Panhandle, it's about 100 foot drop like since 1950. So to meet like this demand, alternative water supply, because the impact of climate change, like with climate change, you will in some region like climate change, you will have like more recharge. In certain region, you'll have less recharge. overall, so that's like, but overall it's not like a big difference in the recharge. Like in some region in Florida you get slightly more recharge, in certain other region you get slightly less recharge, but overall you will, it's not like a big difference as other states would be impacted by climate change with respect to groundwater recharge. But like we will, when we talk about groundwater challenges in next video, we'll discuss this in details. But what I want to show you here is that like groundwater is managed in Florida through several water districts. So you have here's the Northwest Florida. So you have the Swanee River and St. John's Water Management District, the Southwest Florida Water Management District, and then the South Florida Water Management District. So here in Fort Myer and Cap Coral, Stero, Bonita, Springs, Naples, Macro Island, uh, this all Florida Keys, this all like Miami, Fort Lauderdale, Palm Beach. This all falls under the South Florida Water Management District. Yeah. So these are the water management districts in Florida. Okay, so the last slide we have here is groundwater, just as it's important for human use, like drinking water, agriculture, and industrial use. Groundwater is important for ecological use. So here, see this GDE is called like groundwater dependent ecosystem. And here I'm showing like different groundwater dependent ecosystems. So groundwater important for safeguarding ecosystem function and service. So it maintain water level, pressure, and fluxes that are important for these ecosystems to thrive. And then it also provides needed biogeochemical condition like temperature, oxygen, organic matter, dissolved ion, and nutrients also for these different ecosystem to function. Yeah. So here, for example, like wet forests. So you can see some of if you have like here, for example, some of the plant, like you see this plant tree, the roots will go to the groundwater table. That's where they would get their water from. If this groundwater table decline, then this plant will not be able to tap through groundwater. Yeah. So that will plant these types of like wet forests could be affected. So these types of trees, they are called Ferreto Ferretophytes will no longer be able to reach the water table. So increase in groundwater here, for example, the Ferretophytes, like these types of tree, will no longer be able to reach groundwater. Yeah. So what I want you to do, I want you now, like, because I'm not gonna, I mean, be very boring, like, to read through this. What I want you to do, I want you to pause this video, yeah, and just like read these details, like see any groundwater systems that you are interested in, like lakes, for example. We talked about lakes before. Remember, I told you about 500 billion gallons of groundwater contribute to lakes and rivers per day, like in the USA. So check each of these ones and see like the impact of pumping, like when we pump out groundwater and related human activity on these different ecosystems. So this number, for example, one would correspond to here. So check these different ecosystem and check when we pump groundwater, how these different ecosystem will be impacted. So that is here. And then here in this panel, try to read about like the ecosystem service that this groundwater dependent ecosystem provides. So this groundwater dependent ecosystem, they provide like it's usually divided into like four category, like provisional services, regulatory service, culture service, and supporting service. So try to read this service. Okay.